Hello everyone, I'm Santino. I am part of the Chang Lab at UCR, and I'll be talking about some of the research that goes on in my lab.
If any of you have worn glasses, you know that dropping your glasses is always worrisome. Or even dropping your phone, right? That moment when you pick it up and you're not sure if your phone is broken or not. Now, for me, that was enough of a problem that I ended up getting laser eye surgery, so I never had to wear glasses again. But what if I told you that there was a way to get things that looked just like glass, but with the durability of plastic? The research that my lab is focused on is not directly being applied to glasses or phones, but is instead being applied to, as I showed before, these prisms. Now, in our research, we need really high quality prisms, and similar to how glasses are super expensive, these prisms can be very expensive themselves, and depending on what we need, we might need a variety of different prisms. Now, glass is expensive. Not only is glass expensive, but it's also delicate, right? And so that makes it limiting in what we can do with it. Similarly, you frequently have to buy from well-established manufacturers, which means that we can't be creative with how we want our prisms to look. So what we've done is we decided, well, if we can make them out of plastic, and they're pretty clear already, then we can use 3D printing to make any shape we want. And so that's what we have done, is use 3D printing. We can print out a prism, and then through molding, and then recreating said prism again with some smoothing processes, such as with polishing or some chemical processes, we can make not only a prism that's customizable, but also comparable to what is commercially available. Now, not just are these easy to produce and also durable and comparable to what is already commercially available, but they also allow us to do more interesting science. Because if we look here, we can see that we have a beautiful prism, right? Now, this is a different type of prism from the one I showed before, but again, that's just showing how we can use this polymer prisms, this 3D printing, to make different shapes. And as I showed, there is gold directly on the prism. Now, if this was a glass prism, we'd have to clean it afterwards, and that would be a whole ordeal to do so, and we would only have one of these. But the fact that this is plastic, that we have 100 of these, this is disposable. I can make this, I can use it, I can get rid of it. Which is really important if we want to take things out into the field. Because if we're going to a country that, for example, I don't know, doesn't have the monetary funds that the US has, for example, then having cheap optical materials allows us to use our techniques, which are generally speaking used for disease detection, and we can take them and bring them into places that need them most. And so that's just part of our goals, is basically taking optical materials and the techniques that are associated with them and making them cheaper, comparable, customizable, so you can even get better science from them, and then ideally making them maybe not necessarily a product, but at least creating the idea that these can go out into the world and improve sensing capabilities for the general public.
That we have made with gold that has been directly deposited onto the prism, and the second one, a rounded prism that you can see there.